Unit 4 is about rational expressions. So today we're going to look at simplifying, multiplying, and dividing rational expressions. So a rational expression is a fraction, that's the rational part of it, of two polynomials. So you got monomial on top of monomial, you have a binomial on top of a binomial. And those are being divided. To simplify, because that's the first thing we're going to do is simplify. To simplify these rational expressions, we get to factor the numerator and denominator completely, simplify the monomials by dividing the coefficients and subtracting the exponents. And then eliminate, which is the division, eliminate all factors common to the numerator and denominator. Now, just to point this out, we are eliminating factors, okay, not terms. So we got to be careful with that. So as we look at A, they're already monomials. So it says simplify the monomials by dividing. So we can divide a common factor out of 20 and 14. So we're going to divide by 7. That's good. Sorry, not 7. We're going to divide by 2. That's 2. Divide by 2. That gives us 10 over 7. 20 divided by 2 is 10. 14 divided by 2 is 7. And then we will subtract the exponents. So 6 minus 2 is 4. And that's going to put the x's on top because there's more x's on the top than there were on the bottom. So that's going to give us x to the 4th. That is the simplified expression. On the right-hand side, on problem B, we've got some factoring we need to do because we don't have monomials. So with problem B, we're going to factor out a GCF on the top and the bottom. It's going to be 5x to the 3rd, parentheses, x minus 4. On the bottom, there's a GCF of 15. And then that'll give us x minus 4. So, in following the directions that we were given, we have to simplify the monomials by dividing. So we are allowed to divide right here. That's going to give us a 3. 5 divided into 15 3 times. So we'll have a 3 on the bottom. The x cubed doesn't have anything to simplify with, so we leave it on the top. And then the x minus 4s, okay, this is where we are eliminating all factors. X minus 4 and x minus 4 cancel each other out, which leave us with the final answer of just x to the 3rd over 3. And that is simplifying rational expressions. Next up is multiplying. Multiplying rational expressions. So with multiplying, we have to look. Let's look at our problem, and we got a factor, right? We've got to factor any binomials or trinomials. Well, in problem A, there are no binomials or trinomials. Everything is a monomial. So it's going to tell us to multiply the monomials by, let me find the right color, multiplying your coefficients and adding exponents. So let's do that. Let's multiply. Now when we multiply, we actually multiply straight across. This is not a cross multiply situation. So we're going to have one fraction, 6 times 10 is 60. We'll have x to the second, x to the third. We add those together, x to the fifth, and y to the seventh. Okay? So we multiplied the coefficients and we added the exponents. Alright, on to the bottom. 2 times 18 is 36. X to the second, that's the only x on the bottom. And y to the second makes y to the fourth. Alright, so we tried to factor, there was no factoring. We multiplied together. Now we're going to simplify by eliminating all factors common to the numerator and denominator. Which means, let's simplify this fraction. So we're looking for a number that goes into 60 and 36. And that would be 12. So 12 divides into 60 and 36. So that's going to be 5 over 3. Then we're going to simplify the x's by subtracting the exponents. 5 minus 2 is 3. It's going to be x to the third on top because there's more x's on top than there are on the bottom. And then we'll slide over and we'll do the y's. 7 minus 4 is y to the third also. So, we simplified after we multiplied and we got a final answer of 5x to the third y to the third divided by 3. As we move to the B problem, we'll notice that we do have some factoring that needs to be done. So I'm going to rewrite the problem to, supposed to be black, 2x squared over x plus 3 times, we're going to factor out a greatest common factor, so that will be 2x and x plus 3. On the bottom, nothing's going to change there. This is 12x to the fifth. So one of the things you're going to start to recognize is that when you have the same factor on the top and the bottom, they can simplify. Or you can eliminate them. Okay, so simplify by eliminating factors. Okay, we have factors of x plus 3 on the top and the bottom, so they can eliminate each other. After that, we're going to multiply top, top, bottom, bottom. So it's 2x squared times 2x. It's 4x to the third over, the bottom is just 12x to the fifth. We got to simplify that one more time. So 4 divides into 12 3 times. We're going to subtract 5 and 3 as exponents. We'll get x squared. That goes on the bottom because 5 is bigger. And since there is nothing else left on the top, we have to put a 1 on the top, and that is our final answer. Multiplying rational expressions. Our last topic is to divide the rational expressions. So we're on division now. So what we're going to do to divide the rational expressions is we're going to multiply by what's called the reciprocal. of the second fraction. So basically, in middle school or somewhere prior to this, you may have heard of keep, oops, that's not okay, keep, change, flip. Which means to keep the first fraction, leave it alone, change the division sign to multiplication, and flip the second fraction. So that's what multiplying by the reciprocal means. So we're going to keep the first fraction, 5pq over 16p to the third. We're going to change this to a multiplication problem by flipping the second fraction. So 8q to the fifth and 3p squared q squared. So the top fraction, the top became the bottom became the top. So those flipped. And now we're back to a multiplication problem. So let's multiply this together. That would be 40p q to the sixth over 48 p to the fifth q squared. So that's the multiplication, but now we have to simplify the fraction by doing the division of 40 and 48, finding a common term there. So 40 and 48 are both divisible by 8. So if we divide by 8, we get 5 over 6. Slide this over and do the p's. We'll have p to the fourth on the bottom because 5 minus 1 is 4. There's more p's on the bottom than there are on the top. So the answer goes on the bottom. Here with the q's, we'll have q to the fourth because 6 minus 2 is 4, and there's more q's on the top of the problem than there are on the bottom, so that's where the answer goes. So our final division answer, our quotient, is 5q to the fourth over 6p to the fourth. We get to the B problem. Remember that we need to factor. We've got to factor any binomials, trinomials that exist. So as we keep change flip, we need to factor this problem. So there's 4 as a GCF, x minus 2. We need to change this to a multiplication problem and flip the second fraction. So I'm going to flip and factor at the same time. So this is going to the top. So it's going to be x minus 2, x plus 3. And then this is the bottom. GCF, 2x, x plus 3. So we factored and flipped at the same time to just save space. Look for common factors that will cancel. X minus 2 cancels with x minus 2. X plus 3, x plus 3 cancel. And now what we have, when we multiply this back together, across the top you have a 10, and across the bottom you have 8x. And so we get to simplify that one more time. 2 divides into 10 and 8, which would be 5 over 2x. And that is our final quotient for the division of rational expressions.